Good morning, good day, and good afternoon. Thank you for joining us today. My name is Sally Phillips, and I'm the VP of Marketing at Mariner, and I'll be your host today. We have two great presenters today, Josh Hegde from Mariner and Colleen McClintock from Sparkling Logic. So let me go ahead and introduce them. Our first speaker is Josh Hegde. He's a BI solution specialist with Mariner, and he has more than 10 years of technology and business consulting experience. He earned his master's degree in information technology, specializing in IT management and strategy, and also has a Bachelor of Engineering in computer science. He's a Six Sigma Green Belt and has a keen interest in decision management, data visualization, and data management best practices. He's one of the few that's equally comfortable working with technologists as well as business leaders, and he helps Mariner design solutions for our customers. He's also a sought-out speaker on a variety of topics related to BI and analytics. Our second speaker is Colleen McClintock. She's the Vice President of Products at Sparkling Logic, and she's been a leader in the decision management arena since the 1990s when she co-authored an award-winning application to provide business experts with direct ownership and management of business rules. She later joined iLog, where she led the product management and marketing team for iLog's market-leading BRMS, which is a business rules management system called JRules. After iLog was acquired by IBM, she worked with IBM Research on next-generation decision management projects. Colleen is currently responsible for product management and marketing for Sparkling Logic. So now here's a quick view of our agenda today. We'll be discussing both BI and decision management, and more importantly, how the two are related. So now I'd like to turn things over to Josh.
All right, thank you so much, Sally. I hope all of you can hear me clearly. Good morning, good afternoon. Again, my name is Josh Hegde. I will be talking to you about operational BI today. Some people call it real-time analytics, whatever you call it. It's a key part of decision-making today, and it's important to understand the entire landscape of what's happening. I don't intend to get into the weeds of the architectural details of how implementations are being done, but give you a broad overview of best practices, what's going on, and the different approaches that are possible in this space. So without any further ado, let me just jump right into my topic here. I'll start at a high level, giving you an overview of what's happening in the BI landscape, and then get into operational BI. So 2007 is where the story begins. 2007 was a pretty monumental year for BI. In that year, a lot of consolidation took place. The big four, IBM, Microsoft, SAP, and Oracle, acquired pretty much the entire market. A lot of consolidation took place. And the traditional pattern of BI was called corporate BI. It was a classic publishing model of BI, where IT published reports and end users consumed them. There was this kind of wall between IT professionals and end users. And a lot of us thought innovation's kind of over because the industry is consolidated, but then things started to change. Self-service BI took hold. Smaller vendors like ClickView, Tableau, etc. took huge amounts of market share from the big players in the market. Other things started to change. For example, in 2007, there were no vendors who had cloud backends supporting their infrastructure. But by 2010 or 2012, almost all the key players had cloud infrastructure supporting their major deployments. Some of them are now cloud only, like Good Data, for example. Another big thing that's happened since 2007 has been this whole onset of big data. I know it's become almost cliched to talk about big data as the next big thing, but it's actually impacting the architectures of BI that are evolving within enterprises as well to a significant degree, and products have changed to accommodate this whole big data phenomenon quite a bit. So that's been kind of the evolution of BI over the last few years. Lots of changes going on. But in general, if you think about BI, there's still three broad categories. So you have operational, tactical, and strategic. And these are aligned with the key people that they address. So strategic BI is for executives, top-level executives, tactical BI for line of business managers, operational BI for front line workers. Strategic BI is obviously used to drive the business. Operational is more to run the day-to-day side of the business. Typical questions that you would ask within these three categories would be something like this. This is an example. How many people do I need for a shift? That would be an operational type question. Should we be changing vendors is more of a tactical question. Most of the visual exploratory tools in the market now, like Tableau, ClickView, etc., are more focused on the tactical and strategic side. Both these require that aha moment where you come up with this unique insight. Oh, should we change vendors? Let's examine the data, and you come up with something interesting which guides you in that direction. A strategic question may be something like, should we start manufacturing electric cars? It's a big new market. Maybe we need to get into that market. But the focus of this webinar is operational BI, not so much about the tactical and strategic. So let's talk a little bit more about that. The key idea with operational BI is it's all about low latency. Each time I have a conversation with a customer about operational BI, it tends to follow a cliched, almost comical path. The arc of the conversation kind of goes like this. It starts with, oh, we need real-time analytics. What can you do for us? Perhaps, near real-time would be good enough for us. We don't absolutely need it in milliseconds. We need it, in near real-time. And then you begin to ask them more questions. Are humans involved in the process? Okay, so how quickly can humans act on that information? And then it becomes pretty evident really quickly that what they really need is right-time BI. But even that tends to be overambitious. Most customers that we deal with, if there's humans involved in the process, for whatever reason, they tend to be overambitious about what the definition of right time is. If there's humans involved, you better be prepared to create a balanced system where the humans don't become a bottleneck because of their inability to act. And this is important because there is basically a cost associated with lowering latency. It's significantly more development, it's harder to maintain, there's all kinds of complexity costs, so you have to be mindful of just lowering latency for the sake of lowering it. This central challenge of latency can be well expressed with this chart that you see here. This is called the action time. So on the top you see a business event taking place, the big red block right on the top. And as time goes by, there's latency involved. Data latency, analysis latency, decision latency, all the way up till action is taken further along. And that elapsing of time is called action time. But notice the y-axis. There's been a drop in value in the separation from the business event to when the action is taken. So the whole idea is to reduce that drop in value. You want to capture as much value as possible by taking action as quickly as possible. Now, some of you who are listening may be wondering why. Like, is there any scientific basis for, speeding things up necessarily? Well, actually there is. There's something called the OODA Loop, and it stands for observe, orient, decide, and act. It actually comes to us from John Boyd's work with the military in the 60s and 70s, but it's very applicable to operational BI in the world of data as well. In the world of data, our observation would be capturing the data. Orientation would be all the analytical work, the BI work that happens in figuring out how that data makes sense to the business that we're trying to apply it to, and finally you have decision making and action happening at the end. This OODA loop, the central idea here is that if you run through a OODA loop faster than your opponent, you win. It's as simple as that. So you want to compress your OODA loop and get into a faster timeline with which you run through an OODA loop. So if you notice, the biggest component of this over here is the orient part, where you're generating analytic insight. Now Gartner, the analyst firm, has some kind of insight about how this analytic insight is generated. It's not one monolithic mechanism. There's lots of different ways that you can generate analytic insight. And this is how they look at it. Notice it's the same diagram as the previous one in terms of the data pillar, the decision, and the action. It's just the analytic insight piece that I've colored in here. So if at the very top you have descriptive analytics, that's your traditional report, and that requires a lot of human input, and that's latency. That's slowing things down. Then you have diagnostic, why did things happen? This is your classic visual exploration, drill down, drill across. You also have a lot of human input there. Then it comes to predictive analytics. You have data mining and other interesting things going on in this zone. Less human input, so faster decisions happen here. Finally, you have prescriptive analytics. Notice that this is the only zone in which you go from data to action without any human intervention. And so in a sense, this chart is not depicting one thing accurately, that's time, but it is showing you the different flavors of analytics and capabilities that are available to you to go from data to action. Now, when it comes to approaches for operational BI, there is the classic ETL approach, which has been around for a while. There are newer approaches like data virtualization, federation, etc., complex event processing, and more. There's lots of traditional approaches, but now things have changed quite a bit with the onset of big data, and so there's a bunch of approaches associated with real-time big data analytics. I just want to briefly talk about some of these approaches, just so you have a sense of what companies are doing and what the best practices are around some of these approaches. So ETL, if you're not familiar with it, it stands for extract, transform, and load. It works great in data warehousing environments where you have classic structured type data. The key idea here is that you're actually moving data around. So you're putting it into a staging database. I like to think of this staging database almost like a pantry where you're getting all your food from different locations and storing it in your pantry, and then you transform it into a form that's consumable and put it into a warehouse. Now there's many flavors of warehousing. We can discuss the different flavors of warehousing all we want, but the key idea of the ETL is that you're moving data around and it's a batch process. Now, batch processes typically run in off-peak hours, typically in the night, and therefore the latency tends to be of a nightly cadence. Now, for operational BI, that's clearly not enough. So what have people done? They started things like micro-batch ETLs, small slices of trickle feeding your data warehouse throughout the day. Run ETL batches every 10 minutes maybe. That gives you almost a real-time or right-time view of the world. There's also approaches like log-based change data capture. You don't directly go to the data source, but you look at a log file which captures the changes of what's happened and feed that into your data warehouse. So ETL is adapted, but clearly ETL is batch-oriented, not absolutely ideal for real-time analytics and BI. There's another approach which is around virtualization. I've just bundled all of these together: virtualization, federation, enterprise information integration. There's even enterprise application integration. Lots of these technologies and ways to do this, but this is about creating a virtualization layer. I like to think of it as a blanket that abstracts all your underlying data sources. The key idea here is that your data does not move. It stays where it is, but you create an abstraction layer on top of it, which makes it easy for end users to consume your data. So that's just a logical layer that you have, which hides away the complexity. Now, ETL practitioners will tell you, or they'll ask people who do virtualization, so where are you doing your data cleansing? If your data is just staying in its location, does your virtualization layer do the cleansing? Often it's not as good as ETL for that. What about the complexity of transforms that you're doing? Well, oftentimes with the virtualization layer, you can't do as complex transforms as you can with ETL. So that's another drawback. But the big advantage here is you're not moving data. and therefore it is kind of faster. It works, in some ways it works better for real-time types of scenarios. There's complex event processing. Now this is for extremely fast moving data. Let's say there's an NFL game going on or soccer game going on, and scores need to be streamed to consumers who are watching it in their homes. Well, that information is coming from a telemetry source and getting directly beamed through a complex event processing engine all the way to your TV screen. You can't have data sitting in a database and running a batch process, because that data has a very short time to live. Its utility is very short-lived. You need it to be delivered while it's still in motion. You need to analyze it. So typically what people do is use a streaming engine. Here I've shown Microsoft's streaming engine called Stream Insight. But notice there is no database here. It's just data in motion. You analyze it and you kind of deliver it over to a device that can consume it. This is great for extremely low latency scenarios, like even stock market trading. It's good for those types of scenarios. Sometimes not. Sometimes it's overkill for typical operational BI scenarios. And finally, I wanted to talk a little bit with you about the big data approach. If I were to summarize this whole big data approach, it's almost like saying you're trying to achieve the impossible in real time. Because I found it hard to do this with small data, the real-time stuff, and now with big data, the complexity, because of the volume and variety of data, is so much higher. And now you want to do real-time on that? Well, interestingly enough, to meet the challenge, lots of big data platforms are emerging. Now, the ecosystem is still really crowded. There's all kinds of tools like Drill and Spark and Storm and Cassandra and Impala. You won't know which tool to choose for which scenario unless you're really familiar with the space. And a lot of my friends who work much more deeply in big data keep talking about big data being a place where they're almost like dumpster diving. The signal to noise ratio in data is so weak that it's sometimes not worth their time with the amount of effort they put in. But things are changing pretty quickly, and now big data platforms are emerging. Just a few days ago, Microsoft announced their analytic platform system, which combines the worlds of Hadoop and structured data in a very seamless type of way. So things are changing. From an operational BI perspective or a real-time BI perspective, there's a bit of an iron triangle that happens in big data. And it goes something like this. You can have big data and you can have real-time. But if you have both of those, well, don't expect your data to be extremely exact. And this is a classic iron triangle. Or you can have real-time and exact, but in that case, you probably don't have big data. Example of this would be, say, Twitter. Twitter uses Storm product called Storm to figure out what's trending on Twitter. That thing is not extremely exact, even though it is real time and it's dealing with big data. You can have a few tweets that are lost here and there. It's not going to change broadly what you're looking at. But interestingly enough, even this is changing now. Things are becoming even better in the big data world and real-time world. One of the things that's bringing those changes is something called the Lambda architecture. Without getting into too many details, this is an interesting architecture. It has 3 layers. You don't see the 3 layers really accurately on this diagram because that was not my intent. It's got the speed layer, the batch layer, and the serving layer. But the whole idea here is you have batch processing combined with almost something like complex event processing, streaming, mashed up into one unified architecture. Now this is really interesting. This data flows through both these, the batch and the speed layers simultaneously, and you combine them into a query at the end. You might wonder, isn't this, from an architectural standpoint, isn't this an extremely redundant architecture? Isn't it overkill? You could be right in thinking that way, but if you look at this next illustration that I have, you might begin to understand the value of this type of architecture. So if time goes along the x-axis here, you have real-time data coming in. Real-time is messy, inaccurate. And then you have batch data, which is cleaner, more conformed, stable data. As real-time progresses in time, you have more new real-time data coming in. Your batch progresses and actually overwrites what was previously real-time. And so in this manner, real-time moves along and your batch layer basically overwrites what was previously real-time, and it kind of combines to give you a best of both worlds scenario. Very interesting type of architecture that will give you a lot of benefits of real-time along with batch together. So that's enough about the architectures and the types of technologies that are used. I want to talk with you a little bit about sample use cases for operational BI. Real-time marketing. Let's say Shash walks into a retail store. The retailer knows that Shash was on their website. He's tweeted some stuff, shared other stuff on social media. He's also got a history with that retail group and has purchased stuff in the past. What real-time offer can you make him while he's still in the store? You have maybe 10 minutes to make that real-time offer. That's a good case for churning through all the data that you've collected, unifying all the multi-channels that you've collected that data through, and beaming a response in real time. Fraud detection. I purchased something in Charlotte, North Carolina, and 20 minutes later somebody purchases something in Los Angeles. It may be a case for a fraudulent transaction happening there. You want someone to be alerted, you want something to happen in near real time there. Call center optimization. Every call center that you deal with wants to try to not treat you like an undifferentiated mass of people. Ideally, they would want to give you mass personalization at scale, but it's very hard to achieve that because you have some transactional systems which the agents are working with, and then you have data warehousing and other things which they don't have access to. You also have this whole Internet of Things. There's so many use cases within the Internet of Things. In the near future, you may call a cab, a taxi, and it may be a driverless vehicle. You don't want that vehicle notifying your cell phone in 5 hours' time that it's running late. You want it to happen immediately. You may be monitoring a building which has a lot of sensors. You want real-time information to move through the system. Batch processing just will not work in this scenario. You need real-time information. In this manner, there's actually lots of use cases. I'm not going to go through each and every use case here. I do want to spend a little more time on two specific use cases that I worked with much more closely. The first one being a large distribution center. Now, this visual that you see here on the screen, when I was there, it actually reminded me almost of a James Bond movie. You could fit 50 football fields inside of this large distribution center, or perhaps even more. There's hundreds of people working within this distribution center, and they have a war room. Inside the war room, they have these large dashboards which show the team leaders what's happening, what's coming in, what's going out. And these team leads look at the dashboards and decide how to deploy their teams. So what was happening was they were looking at these dashboards and then making notes on paper. They were doing calculations of what they should be doing in terms of what their actions need to be, and then they were going out and doing their work. Their problem was even more basic. Their dashboards were not refreshing fast enough, and they were going down because of people hitting refresh too often, and so they just wanted something which consistently refreshed within a 10-minute window. And they were happy with that. They were happy with just looking at the information on the screen. But it became apparent to me in retrospect that something critical was missing here. Just giving them information was not enough. We could have done something a little more than just give them that information and then have them figure out what action needs to be taken. That's one example I want you to keep in mind. And you'll see how this scenario could have been completely well handled if we had done one little thing extra. Another scenario I want to talk about is call center operations. This is for a large bank. The central idea they had was what if the agent on the floor knew if a high-value customer is calling, and that, so where's the information for that high-value customer? Well, it's in a data warehouse, and we have a score for every customer. Couldn't we surface that score in front of the agent in the time the call is taking place? Yeah, sure we can. Then they said, oh, what if we could also surface a risk score? A risk score that this customer is going to churn. We have a predictive model which has figured something out. Why don't we surface that? And why don't we surface this? And why don't we... So it became a series of metrics and things that they wanted to surface. No one asked the question, why don't we just focus on letting the agent have a human connection with the person calling and not inundate them with too much information? So the whole idea was supply as much information to the agent as possible in near real time and expect that the agent should be able to take the best course of action. Now that seems reasonable theoretically. It doesn't quite work because behavior change is hard, and agents have other pressures on them. Oh, you got to reduce average handling time, but you're also throwing so much information at me at the same time. How am I going to cope with all of this stuff? So things were... What I wanted to summarize here was there's something missing here again. We kept focusing on giving them more information, but there was a missing ingredient here. And that's kind of what we want to focus on next, which is in operational BI, information is typically not enough. Just giving information is not enough. In fact, information at the right time to the right person in the right format is also not enough. Because you have a human being involved in some of these cases, and if the human being is involved, well, you're going to run into issues. So what do you really need? You need action. You need an ability to take action. So in this next part, I'm going to hand off to Colleen, and we're going to talk about how operational BI gets completed, it becomes whole, if you have something called decision management tied in with operational BI. And so at this point, I'm going to hand off to Colleen.
Thank you, Shash, for that excellent introduction. So, operational business intelligence, as Shash described, provides insight on your business operations and can enable your frontline workers to make informed decisions. But also, as Shash said, insight delivered in the right format to the right people at the right time is often not enough. And you need to make decisions based on that insight in order to take action. And decision management systems can automate your decisions and determine the correct action to take in a specific case based on data insight. So, for example, in an insurance underwriting or in a loan or credit approval, analytics can tell you which of your customers are high or low risk, but the correct action requires a decision. And decision management can automate this decision to decline or refer your high-risk applicants and decrease the price for those who are low risk. Another example might be in retail, where BI and analytics can provide insight into your customer behavior, and decision management systems can turn that insight into action by recommending upsell or cross-sell offers to customers based on their past orders and preferences. And in the Internet of Things, where devices are instrumented with microchips and sensors, analytics can tell you the current state of your assets, and decision management can recommend specific actions, or it can raise alerts for identified conditions. So decision management is both a discipline and a technology. Next slide, please. A discipline and a technology that's focused on automating and improving operational business decisions. And by operational decisions, we mean those decisions that are repeatable at high volume and are good candidates for automation and improvement. And any decision that's automated in software and that's subject to frequent changes due to new or updated policies or regulations, or perhaps due to changing business and market conditions, is a good candidate for decision management. Decision management can also automate decisions that currently require frontline workers and customer-facing employees. For example, a call center representative who needs to decide which promotional product to offer to each customer. So when these decisions are automated, your frontline workers can focus on handling more complex cases and exceptions. And in decision management, the way this works is your decision management, your decision logic is defined. Next slide, please. Your decision logic is defined in the form of executable business rules. And business rules are simply statements that specify the actions you take when certain business conditions are met. So here is a very simple example of a business rule in an auto insurance underwriting application that simply offers its count when multiple vehicles are covered under the policy. So let's look at the high-level architecture of decision management systems. There are three primary components. First of all, there's a decision management interface, there's a decision management interface, a decision repository, and a decision execution service. And the decision management interface is a powerful and intuitive environment where your business experts can author, maintain, and govern your decision logic. And this decision logic is stored in a decision repository so that it can be shared between your decision authors and project stakeholders. And the decision repository not only persists the decision logic, it also provides services like access control and security, and audit trails, and versioning to keep track of changes that you make to your business rules. And once this decision logic has been validated and tested, the decision is deployed to a decision execution service where it can be invoked by your business applications and processes through a simple API. So let's take a closer look at how you go about setting this up. So the way it works is all organizations have core business processes that rely on these operational business decisions. Next slide, please. And traditionally, either frontline employees have made these decisions or the decision logic has been automated by hard coding it in the process in the application. And there are problems with both approaches. So as Josh pointed out, human decision-making can be slow and error-prone and inconsistent. And when decision logic is automated, you overcome those errors and inconsistencies, but it's very difficult to keep the system updated with changing market conditions or changing policies and regulations, because IT support is needed even for routine changes, and it can take weeks to analyze and implement them. So as we saw in the previous slide, in decision management systems, your decision logic is actually separated from your business processes and systems. It's extracted from those business processes and systems, and it's managed in a separate environment so that it can be controlled by your business experts, and it can be changed independently of your systems and processes. So a key focus in decision management is in isolating your decision logic from the processes and systems so it can change independently and so that it can be managed in a separate environment that gives your business experts control over that decision logic. So the way you go about obtaining this decision logic is you extract it from various sources within your organization. And this can include your applications, which could be legacy applications that are being modernized, or your decision logic could be extracted from directly from business policies. Back on the previous slide, please. Oftentimes, if it involves human decision making, you're going to extract that decision logic from your business experts so you can elicit how they make decisions based on their expertise. It can also decision logic is actually embedded in a quite complex business process. Secondly, it comes from your data, since your data can be a source of information that guides your decision. And the decision logic you extract from these sources is captured in the form of explicit business rules in a repository where it can be accessed and managed through the decision management interface that allows the business analysts and business experts to author and govern those business rules. And again, it's deployed to a decision execution service where the decision results can be monitored, measured, and improved over time. Please. So to tie this together a little bit with operational BI, when operational BI or operational analytics is combined with decision management, you're combining either historical or perhaps real-time data, that could come from a data warehouse or a more real-time architecture as Josh described, and you're combining that with current information or transactional data from an operational process. And this information represents the information required to make a decision at a given point in time. And it's passed to the decision service, which executes the organization's preferred decision-making approach and returns the output, which would consist of the decision outcome and recommended action. So there are several benefits to this approach, and I just want to take a closer look at each of those, at some of these benefits. So the first is decision management provides real-time responsiveness. And it wasn't so long ago when customers understood that complex decisions take time. So, for example, when you applied for a mortgage, you would complete a loan application and submit it to your bank or mortgage originator, and then you would wait days or even sometimes weeks to get a response back on whether or not your application had been accepted. But today, your customers and your suppliers and partners expect more immediate responses. So, for example, today we can go online and apply for credit instantly in a retail store, in an online retail store, and we can immediately use that credit to purchase the items in our shopping cart. Or we can complete a form on the web and instantly be approved and receive a quote for insurance. So the problem is, since most organizations still have people involved in many of their processes, they often have difficulty delivering in real time. And even though people are more flexible and understanding, they take longer to do things manually. So only automated systems can respond in real time. And in the real-time world, the behavior of your automated systems matters, and this is where decision management can help. Another benefit is that decision management can reduce errors and increase the consistency of your decisions. So in our insurance claims processing, when claims examiners are manually processing claims, they have to determine the eligibility for payment and the amount covered under the policy. And with human claims examiners, errors are common and can easily happen. And there's not only a lack of consistency between one claims examiner to the next, even the same examiner can be inconsistent in their decisions from one claim to the next. So by automating the claims decision using decision management, you can eliminate errors and ensure consistency. And compliance is another key benefit. And this is because many organizations need to ensure that they're in compliance with regulations that exist for their market or industry. And this is important because policy and regulations are constantly changing, and you need to be able to respond rapidly to those changes. So since decision logic is deployed to a decision service that can be invoked by multiple applications and processes, decision management technology can ensure that your policy is administered reliably and consistently across your applications. And the next benefit, with decision management, your organization can benefit from the increased transparency of the decision. And what I mean transparency is the ability for your organization to understand and control its automated decisions. And we all know this problem where frequently a legacy application will be making a decision that neither the business nor IT fully understands because the decision logic is buried in executable COBOL or C++ or Java code. And since decision management can represent this decision logic clearly and explicitly in the form of business rules with a shared decision repository, it's clear how a specific decision is reached. And finally, agility is perhaps the most widely recognized benefit of decision management. By giving your business experts control of the decision logic, your organization can directly benefit from the increased agility of your applications and processes. And this agility results from two things. First of all, it results from the ease and speed with which you can change the behavior of your applications. And they can be easily changed since the decision logic is represented in the form of business rules that can be modified or extended without changing the underlying application or process invoking the decision. And agility also results from the fact that the decisions are loosely coupled with the applications and processes that invoke them, so that they can be changed independently on their own cycle as needed. So in automated decisions, agility is critical because what constitutes a good decision can change. So it's really a good, or whether a decision is a good one or a bad one, kind of a moving target. For example, a decision that you want to offer a discount on a particular order for a customer may be competitive today, but tomorrow, when a competitor changes their pricing, it may be less competitive. So now I'd like to look at a few concrete examples of companies that are using decision management. And the first company is a high-profile online payment processing company that's using decision management to detect flash fraud. And the problem with fraud is, of course, new fraud schemes are continuously arising. And prior to using decision management, it was taking this company about 2 weeks to build and deploy the analytic models that they needed to detect new fraud schemes. And of course, during that time, the fraudsters continued to use the scheme that they had discovered. So the company was, was losing a lot of money. But today, they use our product, Sparkling Logic Smarts, to analyze fresh data with recently reported fraud cases. And they use rule mining techniques to induce rules from that data, and they refine those rules based on their expertise. So using this technology, it now takes them a day, down from 2 weeks, to create and deploy these new fraud detection schemes. So they're saving significant amounts of money by eliminating fraud earlier. The second application I want to talk about is a healthcare insurance wellness program. Next slide, please. So this company is a leading health and wellness company that's using smarts to detect the participants who are at risk for health issues and recommending courses and coaching to help them improve their health and reduce their risk. So they're also using smarts in that application to provide incentives to the participants so that they can offer tailored bonuses and rewards based on the participants' participation and outcome. So in both companies, the decision logic is entirely managed by their business experts and business analysts. There's no IT involved in making and deploying those changes. So these aren't the only examples of decision management. Because decision management is a horizontal technology, there are many more applications. Leading companies in financial services, healthcare, and utilities are using decision management to improve the quality of their operational decisions. So I hope this gives you a high-level understanding of what decision management is and how it can complement and build upon operational BI. And now I'm going to hand it back to Sally to conclude the webinar and take any questions you might have.
Great. Thank you, Colleen. Thank you, Shosh, as well. So I just want to take a few minutes. If you're intrigued by what you saw today, I strongly encourage you to contact any one of us, and we have our emails there, and consider doing a jumpstart. During a jumpstart, we identify a single high-value decision to test the tools and methodology to determine if decision management is really a good fit for you and your organization. You get to test Sparkling Logic's Smarts tool, and you get to know the Mariner consultants and see if this is a path you want to take. You should also join us for our next webinar, which is next month, Friday the 16th, in which we'll go into much more detail about decision management and actually demonstrate the tool and processes behind automating and improving decisions. Feel free once again to contact any one of us, and we will provide you with any other additional information you may need, and also be on the lookout for your invitation for the next webinar on May 16th. Thank you. Have a good day.